All right, let's jump right in. I want you to do something for me. Just picture it. The year is 2026. You're walking down a familiar street in your city. What do you see? Well, spoiler alert, still no flying cars. I know, we're always promised flying cars. But if you look a little closer, something way more radical has actually changed. Yeah, that's it exactly. The real revolution, it's not happening up in the sky. It's happening inside the very walls of our buildings. We're talking about intelligence woven right into the structure, and get this, even into the very dirt they're built on. Our buildings are becoming this incredible mix of high-tech data and, surprisingly, deep, earthy sustainability. So how in the world are we getting there? Well, we're going to break it down into four main ideas. First, we'll tackle the tech side of things, what I'm calling the digital backbone. Then, we'll get into this fascinating trend, our return to Earth. After that, we've got to look at the invisible foundation that makes it all possible. And finally, we'll pull it all together and ask, what does this mean for the new human architect? Okay, let's kick things off with that digital backbone. You see, the foundation for this whole new reality is a technology you've probably heard about. It's called BIM. But trust me, it's way, way more than just another buzzword. Now, what's so cool about this definition is that it flips how we normally think about BIM. We see a 3D model, right? But it's not just a model. It's actually a massive, living database that just happens to look like a building. So if you move a wall in the model, boom, the database instantly updates the floor plan, the list of materials, even the budget, everything. It's what we call the single source of truth. And this isn't some pie-in-the-sky future tech we're talking about. A full 68%, two-thirds of professionals are already using BIM. It's the baseline for today. But this is where things get really, really interesting. Because the next step, the next evolution, well, it's already here. And its name is artificial intelligence. And the key here is a huge shift in how we think about AI. We hear all the time about AI automating boring stuff. And sure, it does that. But the real game changer is thinking of it as a creative partner. We're moving past simple automation and into actual, genuine collaboration. So what does that partnership actually look like? Well, it's a process called generative design, and it works kind of like this. First, the human architect lays down the rules. Things like, okay, the building is here, it needs this much natural light, and we have to use these specific materials. Then the AI goes to work, generating thousands, literally thousands, of design options, many of which a human would never even dream up. But, and this is the most important part, the human provides the final judgment. The AI can tell you what's efficient, but it can't tell you what feels right. That's still our job. But AI's job doesn't end when the design is done. Oh no. Once we move to the actual construction site, the training wheels are officially off. You gotta remember, construction is an industry with razor-thin profit margins. So now you've got these AI digital workers starting to handle finance, risk, and operations, analyzing data that's just minutes old, not months old. It's a total paradigm shift. And all of this leads to this incredible concept, the digital twin. Think of it as a perfect virtual mirror of the physical building, but it's alive. It's connected by a whole network of sensors that are constantly feeding it real-time data. It's almost like the building has its own nervous system. So it doesn't just tell you, hey, a pipe burst. It can actually predict that a pipe is about to burst, all because it detected some tiny weird vibration a few days ago. Incredible, right? Okay, but here's the twist. Here is the paradox that honestly just blew my mind when I first dug into this. Even as our buildings are becoming these hyper-intelligent, data-crunching machines, they're also getting, well, earthier. And that brings us right to our second pillar, a return to Earth. I know, it sounds completely contradictory, doesn't it? One minute, we're talking AI and digital twins, and the next, we're talking about a massive comeback for ancient natural building materials. But it turns out, we're using these old-school techniques to solve some very modern problems. I mean, it's a totally fair question, right? Why on earth would we go back to using literal dirt in the form of rammed earth when we have super advanced modern concrete? Well, the answer is surprisingly simple. Because dirt works, and it works incredibly well. The secret sauce here is a scientific principle called thermal mass. Basically, it's the ability of a material, like a really thick earthen wall, to absorb, store, and then later on, release heat. And this is just the perfect way to think about it. It's like a battery, but for heat. So during a hot day, those thick walls are just soaking up the sun's heat, which keeps the inside of the building nice and cool. Then, at night, when the outside air gets chilly, The walls slowly release all that stored heat back into the building. It regulates the temperature all by itself. We're talking massively slashed energy bills, all thanks to some cleverly packed dirt. This same focus on sustainability is what's driving this huge trend of adaptive reuse. For decades, the default was just demolish it and build something new. But now, the industry is realizing that taking an old historic factory or a warehouse and giving it a new life, well, it doesn't just honor a city's past, it also drastically reduces waste. And a huge chunk of that waste is something called embodied carbon. The best way to think of it is like this heavy, invisible backpack a building wears from its very first day. It's all the carbon that was emitted just to create and transport its materials. And now we have these calculators that let architects see that carbon cost right up front, forcing them to make smarter choices. It's kind of like counting calories, but you're doing it for the planet. So we've designed our amazing, high-tech, nature-loving building. Great. Now we actually have to build it, without the whole project going bankrupt or falling apart. And this brings us to our third pillar, the invisible foundation of economics and engineering that makes it all possible. At the heart of every single construction project is this classic dilemma, the iron triangle. You've got time, cost, and quality. And here's the catch. You push on one, and the other two are always affected. The pros who have to manage this super delicate balancing act, they're called construction economists. Their whole job is to keep this triangle stable, making sure a project ends up as a beautiful, finished building instead of, one of those abandoned concrete skeletons you see sometimes. And a really crucial piece of this invisible foundation is safety. A lot of times when we think about fire safety, we think of reactive stuff, right? Sprinklers, alarms, things that go off after a fire has started. But the real shift is towards proactive, passive systems. We're talking about fire-rated walls, special smoke dampers, and clever building layouts, all designed right into the architecture to stop a fire from ever spreading in the first place. Okay, so we've covered the tech, the nature, and the numbers. But there is one last, essential piece that holds this entire puzzle together. Because you can have the best design in the world, but if you can't sell the vision, if you can't synthesize all these complicated parts into a story that people understand, it's all for nothing. And this is the new role of the human architect. So here's the big takeaway. Engineers and architects have to learn how to communicate value. And a really powerful way to do that is to frame your client as the hero of a story. Their problem, maybe it's high energy costs or an unhappy workforce, that's the dragon they have to slay. And your building isn't the hero of the story. It's the magic sword you hand to the hero so they can win their battle. So let's pull all these threads together. What is a building in 2026? It's this incredibly complex ecosystem. It's designed in partnership with an AI. It's grounded in natural, earthy materials with a low carbon footprint. It's managed in real time by a digital twin. It's kept on budget by construction economists. It's made safe with proactive engineering. And the whole thing is built on a foundation of clear communication that always puts the client first. And this synthesis, this new reality, it leaves us with one last really big question. If the computer can generate thousands of optimal designs, and if it can manage the building's daily operations, then what exactly is the future role of the human architect? I mean, are we making ourselves obsolete? I don't think so. Not at all. The human role simply evolves. We're no longer just the designer of walls. We are becoming the designer of systems. We're the conductor of this massive, amazing orchestra of AI, data, and nature. Because you see, the AI can optimize a wall for wind resistance, but it can't understand human delight. It can't capture that feeling of home. In this new world, the human element, our judgment, our taste, our empathy, becomes more important, not less. We're the ones who guide all these powerful tools toward a future that's actually good for people and for the planet.